Our next unit is on chemical reactions. So as you go through this PowerPoint and listen to me, make sure you fill out the notes that you have. And at the end of the notes, there's extra practice. So there's 2 that you need to do on your own. You already know how to name compounds, so you'll be naming that compound and counting the atoms. There's a video to introduce this, but we're not going to watch it through this recording. I will attach it as a separate video to watch. Alright, chemical reactions. This is when we have one substance changing into another substance. So we're going through a complete change, and we have defined this before at the beginning of chemistry, so this is not a new definition. A chemical reaction is the process by which one or more substances are changed into one or more different substances, or we can say they have gone through a chemical change. In chemical reactions, we have bonds between atoms or substances that are broken. The atoms get rearranged, and there are new bonds that form. And this creates totally different substances that have different properties. A chemical reaction is represented by a chemical equation. There are 2 parts to a chemical equation. We have the reactants. The reactants are on the left side, and these are the substances that are going to combine to produce a new substances, or it could start out as a compound and then we are breaking it apart. The other part of a chemical equation are the products. These are the products that are formed based on the reactants that we start with, and they are also to the right side of the chemical equation. So this is an example of a chemical equation. This is a basic equation that we use for water, the formation of water. So to make water, we have hydrogen gas, which is H2, and combines with oxygen gas, which is O2, and produces water, H2O. This arrow here means yields. So hydrogen gas plus oxygen gas yields or produces water. How do we know that a chemical reaction has happened? So there can be an energy change. So heat's given off or light's given off. So a lot of times when you're doing a chemical reaction lab, you will feel the test tube. We did some chemical reactions at the beginning of the year with those Ziploc bags, and you were supposed to feel the bag to see if the bag got warm or not. So the production of heat or light. Also the production of a gas. How do we know a gas is formed? There'll be bubbles and it will fizz or smoke. And we also had this in that same lab we did with the Ziploc bags. There might be a change in color. So if there's a change in color, many times that indicates a chemical reaction. Or a formation of a precipitate. And we will define that in this PowerPoint. So a precipitate is just what is shown in this picture. It's a solid that's produced when we have 2 liquids that come together. So in this situation, we have a clear liquid in the test tube, and then in this pipette up here, there's a yellow liquid. The yellow liquid goes in, and we have this rust color solid that forms. And so this solid is what we call a precipitate. And a couple of things we need to remember from when we first started talking about physical change and chemical change. Change of state, so from a solid to a liquid to gas, that is not a chemical reaction. That is not a chemical change. So melting, freezing, condensing, all of those things, those are just a physical change. We also need to remember that dissolving something, dissolving is not a chemical change. it is a physical change. So if we dissolve salt in water or sugar in water, it is still there. You can still taste it, and we can get it back by separating it. One law that we have to be aware of is the law of conservation of mass. Atoms are neither created or destroyed in chemical reactions. All we do is rearrange them. So the number of atoms has to be the same on one side as it does on the other. We also have to have the same mass. So the same number of atoms on each element must appear on both sides of the equation. So where the arrow is on both sides, and also the mass is conserved. In order for an equation to correctly describe a reaction, we have to make sure it is balanced. So that's one of the new things we're going to learn how to do in this unit, is balance chemical equations. According to the law of conservation of mass, the total mass of reactants, the mass of the reactants must equal the mass of the products, and we're going to learn how to do that and show that as well. Before we begin to balance the equation, we have to know what the word coefficients means and what they are and how to use them. So a coefficient is a whole number that appears in front of a formula in a chemical equation. Coefficients are numbers placed in front of a symbol or formula, and we use them to balance equations. And so here's an example. We've got our basic water equation, and then we have these 2's in front of this H2 and the 2 in front of H2O. We never alter a subscript when trying to balance a chemical equation. So these smaller 2's are subscripts. We cannot change those. If we change those, if we change these subscripts, we are changing the compound. It is no longer water, or it's no longer hydrogen gas or oxygen gas. We cannot change the subscript. So the coefficient here is this large 2 right here, and our subscript is this one right here. So make sure you know the difference between those two. So we need to become experts in counting atoms, and we did a little bit of this in the last unit, but we're going to be doing a lot of it now. So how do we count atoms? We're going to take the subscript and multiply it by the coefficient. If there is no coefficient, we understand it to be 1. So for example, now we know how to name these. This is disilicon trihydride, so this is a covalent compound, and we are going to count the number of atoms. So we want to look at the subscript here. So for silicon, we have 2, and we multiply it by the coefficient of 4. So 2 times 4 is 8. That means we have 8 atoms of silicon. For hydrogen, we're going to take this 3. We're going to take the 3 and multiply it by 4 to give us a total of 12. So we have 8 silicon and 12 hydrogen. Here's another example. You should recognize this as an acid, because I've told you that any compound that starts with an H is an acid, and this should look familiar. It's in our notes from the last unit, and we've named it several times. This is sulfuric acid. We have 2 hydrogens in the formula. So I'm going to take the 2 and multiply it by this 2. That gives me 4. So that's 4 hydrogens. And then sulfur, there's a 1 here. I'm going to take the 1, multiply it by 2 to give me 2 sulfur. Oxygen, you take the 4, multiply it by 2 to give you 8 oxygen. So we have 4 hydrogen, 2 sulfur, and 8 oxygen. This is another compound you should now know how to name. We have calcium, which is a metal, so this is an ionic compound. OH is a polyatomic ion, which is on our reference sheet. So this is calcium hydroxide. So we have 3 calciums. My 1's here, 1 times 3. And the oxygen, I have the 2 on the outside, so that means 1 times 2. And then I also have to multiply it by this 3. So 1 times 2 is 2 times 3 is 6. And then the same with hydrogen. 1 times 2 is 2 times 3 is 6. So we have 3 calcium, 6 oxygen, and 6 hydrogen. So I'm going to do one more example. This you should also be able to name at this point. Aluminum is a metal, so this is an ionic compound. SO4 is sulfate, which is a polyatomic ion on our reference sheet. So we have 2 aluminums, and we multiply it by this coefficient of 2. That gives me 4 aluminums. For sulfur, there's a 1 here, times the 3, and then times the 2. So 1 times 3 is 3, times 2 is 6. Then oxygen, we have 4 times 3, which is 12, times 2 is 24. So you have 4 aluminum, 6 sulfur, and 24 oxygen. So those are 4 examples that I went over with you. You now have 2 examples in your notes that you need to practice on your own. You're going to write the formula for the compound name, because we know how to do this at this point. And then you're going to count the atoms. So make sure you finish that, and then you will have a worksheet to complete using your notes.